Okay, let's do 11.3. Again, read your book. It's very important you read your book. Okay, so last time we saw that the summation n equals 1 to infinity of 1 over n diverge to infinity. Now we're going to look at n equals 1 to infinity of 1 over n squared. Where does that guy go? We've already kind of talked about this, and we alluded to the fact that guy blows up. This guy doesn't blow up. This guy actually converges. So let's look at it and see what happens. Now, first thing you should always do when you're looking at a series, does the stuff on the inside, the sequence part of it, does that go to 0? In this case, this guy did go to 0, but it blew up. You got to check this guy. Is this guy going to 0? Yes, this is going to 0, so this guy might converge, it might not. If the insides don't go to 0, you don't have to do anything. You just quit saying it doesn't, does not converge if the insides do not go to 0. If the insides goes to 0 here, I don't know if it converges if it doesn't converge. So we're going to start something called the integral test. So let's look at the summation n equals 1 to infinity of 1 over n squared. Well, that equals 1 plus the summation n equals 2 to infinity of 1 over n squared. Okay, all I did is pull off first time. Taking the first time, taking a 1, you get a 1. And so that's all I've done. Now let's see what this looks like. This is 1 plus 1, sticking 2, that'd be a quarter, plus sticking a 3, you get a ninth, plus 1/16, plus 1/25, plus dot, dot, dot. And so this out forever, that's the summation n equals 2 to infinity 1 over n squared. Now I'm going to look at the function f of x equals 1 over x squared, and I'm going to graph it. Graph looks like sticking a 1, what do you get? Sticking a 1, your output's going to be 1. Sticking a 2, what's your output going to be? Sticking a 1, you get a 1. Sticking a 2, you're going to get 1/4. You get 1/4, and the function looks like this, and it dies off pretty quick. Now, let's go from 2 up and over, and then we'll go to 3 up and over, from 4 up and over. Let's figure out what's the area of these, and I'll draw them red here. What's the area of these red boxes? What's the size of that guy? It's 1 wide. How tall? It's 1/4. So it'll be 1/4 will be the size. How this one's 1 wide. Its height will be 1 over 3 squared. So that guy's going to be 1/9. That guy's going to be 1/16. And look at that. The area of these boxes is exactly the same as this piece right here. Now let's look at the integral. The integral is going to be all of this. So what's the difference in the integral in the area of these boxes, which is this sequence, this series? This part right here. Who's bigger? The integral or all these boxes? Looks like the integral is. So I've got that the integral from 1 to infinity of 1 over x squared dx is bigger than the summation n equals 2 to infinity of 1 over n squared. So we're working on this piece. What I'm going to show is this guy converges. So let's look at that integral. So that's going to be the limit b goes to infinity of the integral from 1 to b. I'm going to write that as x to the minus 2 dx. So this equals the limit b goes to infinity. Okay, you're going to add 1 to it, so you're going to have x to the minus 1 and a minus here. So bring that to minuses will die after that's from -2, so that's the correct integral. And we got 1 to the b. So that's going to be the limit. B goes to infinity. Sticking your b, so you're getting minus 1 over b. Sticking your 1, so you get a minus 1 over 1. Okay, now as b goes infinity, that's 1 over a number getting bigger and bigger and bigger. This is going to go to 0. And minus minus plus, so this is actually going to end up just being 1. okay? So what's that tell us? The integral, this integral right here equals 1. So this sum is equal to 1 plus this. So that's going to be less than 1 plus the integral from 1 to infinity of 1 over x squared dx, which is equal to 1 plus 1, 2. So what do you know? You know that the summation n equals 1 to infinity of 1 over n squared is less than 2. What is it actually equal to? I don't know. I just know it's less than 2. Is this thing right here, what can you say about Sn and Sn plus 1? Who's bigger? This guy got one piece added onto it. I added a positive number. Yeah, it's positive. These guys are increasing. That guy's squared. So I added a positive number, so I know that's happening. What does that mean? That this sequence, which is made from this series, is increasing. So it's monotonically increasing. And is it bounded? Yeah, it's bounded by 2. So it's increasing and bounded by 2. So I know for a fact this guy converges. What does it converge to? I don't know. Euler figured it out. It's in your book, the exact answer, but proving it is a little beyond this course. Okay, let's look at another one. What about the sum n equals 1 to infinity of 1 over square root of n? Well, let's see what happens there. So I'm going to look at the function f of x equals 1 over square root of x. What does the graph of that function look like? When you stick in a 1, you're going to get an output of 1. When you stick in a 2, you're going to get an output of 1 over the square root of 2. So that function is decreasing, not quite as fast as the other one was. And you stick in a 3, you're going to get 1 over the square root of 3. Now let's look at the boxes this way. Now who's going to be bigger? Let's almost make sure that these are the sums. How big is that guy? There's 1 high and 1 wide, so it's going to be 1. How big is this guy? It's square root of 2 high, 1 over square root of 2 high, times 1 wide, so it's going to be 1 over square root of 2. The area of that box will be 1 over square root of 3. Well, what's this sum equal to? This is going to be 1 plus 1 over square root of 2 plus 1 over square root of 3 plus dot, dot, dot. So if I add up all these boxes, they're exactly equal what that series is. Now let's look at the integral. The integral is less than, so I do know this. The integral from 1 to infinity of 1 over square root of x dx is less than the summation n equals 1 to infinity of 1 over square root of n. I know that. So what I'm going to do is I'm going to show that this blows up, and that's going to make that blow up. So I'm going to erase our picture here. So let's look at this integral. So the integral from 1 to infinity of 1 over square root of x dx. Okay, that equals a limit. B goes to infinity. Integral from 1 to infinity, 1 to b. I'm going to write that as x to the minus 1/2. Yeah, it's the same thing. Okay, so what's this integral going to be? Just do to find the antiderivative of this guy. So it's going to be the limit. B goes to infinity. And antiderivative, you can add 1, so it's going to be 1/2. And that's going to be 2. Make sure it's right. Take the derivative of this. Multiply that times that turns into a 1. And that's going to be negative 1/2. That's what we got. So that's what we want. We evaluate this from 1 to b. And that equals the limit. B goes to infinity of 2 times the square root of b minus 2 times the square root of 1. As b goes to infinity, that blows up, minus 2, who cares? That's equal to infinity. Okay, so what we got is that this guy equals infinity, and that guy's bigger than it, so what do you know about this thing? It has to diverge to infinity. Okay, so now I'm gonna lay down exactly what the integral test is. So read it in your book, it's better than what I'm fixing to say, but I'll try to write it down here. Gotta get all the pieces. The integral test. If f is continuous, decreasing, positive, on 1 to infinity, and f of n equals an, then the summation n equals 1 to infinity of an converges if and only if the integral from 1 to infinity of f of x dx converges. Okay, what does that mean? You've got an integral, you've got a series you're looking at. Find a function that matches each one of your pieces at the integer. So at 1, it gives you what a1 is. At 2, it gives you what a2 is. 3, it gives you what a3 is. And if that function is continuous, decreasing, positive on this integral, and if the integral of that guy, if it converges, the series converges. If it diverges, the series diverges. That's what if and only if means. Again, it's a pretty powerful theorem, and we're going to use it to prove the p-series. Okay, so let's look at p-series. What's p-series? Here's the p-series. If you got a sum n equals 1 to infinity of 1 over n to the p, this converges if, let's look up here. When p was equal to 1, it blew up. And here p is equal to what? P is actually a half right here, and it blows up. P is equal to, it converges. So it looks like if p is bigger than 1, it's going to converge, and it's going to diverge if p is equal to 1 or p is less than 1. And we can put that together and say, so p is bigger than 1, good. If p is less than or equal to 1, bad. Okay, now let's prove it using the integral test. Let's look at the integral from 1 to infinity of 1 over x to the p. Okay, now, is this positive? Well, my x's are positive. Is it decreasing? Well, this is 1 over, these numbers are getting bigger, so it's always decreasing. Is it a continuous function? Yes, as long as it stays away from 0, it's continuous. So it's positive, decreasing, what else I got? And it's continuous. Positive, decreasing, continuous. Does it match this guy? It's stick in a 1. You get it 1 over 1 to the p. So it matches on the integers. So this has all the parts that the integral test needs. Let's just figure out what this ends up being, okay? So that's going to be the limit. B goes to infinity of the integral from 1 to b of 1 over x to the p. Now we'll rewrite that as x to the minus p dx. I mean the dx here. Y'all for that, so I should do it. Dx, so that's going to equal what? Limit b goes to infinity of x to the minus p, and add 1 to it, and you can divide by minus p plus 1. Okay, so I took the antiderivative of this guy, and I got to evaluate that from 1 to b. So this equals limit b goes to infinity. Plug in your b, so you get b to the minus p plus 1 over a minus p plus 1 minus, plug in your 1, you get 1 to the minus p plus 1 over minus p plus 1. Now you decide if this is going to converge or not. And really the only thing I got to worry about is this term right here. Is this going to converge? Well, I'm taking, b's getting bigger and bigger and bigger. So I need to put it on the bottom. I need this thing right here to be a negative number. That's going to be a negative number. Now let's plug in some values. If p was equal to 2, a minus 2 plus 1 is a negative number. If p was equal to 1, that's going to be 0. That's going to screw this whole thing up. So p can't be 1. I have to go back and look at that case separately. But suppose p was equal to a half. I got a minus 1/2 plus 1. That's going to be a positive number. Raising something going to infinity to a positive power is going to blow up. I got to make sure this guy right here, a minus p plus 1 has got to be less than 0. Okay, so let's take this across. We add p to both sides. So this will give us 1 is less than p. So for this guy to work, p's got to be bigger than 1, which is what we said. Now the only case is, now if p is less than 1, what's going to happen, p is less than 1, it's like a half, that's going to be a positive number. And so this thing's going to blow up. What happens if p is equal to 1? P is equal to 1, what's going to happen? I'm going to get the integral from 1 over x to the p, which is 1. I get that guy, dx from 1 to infinity, and that's going to be ln of x from 1 to infinity, which is going to be, again, I'm doing bad math here. That's going to be ln of infinity minus ln of 1. So what's ln infinity? That's infinity minus 0. So this guy's going to be infinity. It's going to blow up too. So the only time it's going to work is if p is bigger than 1. Worked here. And that's your pieces. Again, read it in the book. It lays it out a lot better than I did here. Let's look at some examples real quick, and then I'll let you go. Well, I think summation n equals 1 to infinity of 1 over the 5th root of n is going to be. What's p going to be in this case? Let's rewrite it. Again, it's a little too simple. We get some hard ones in homework. It's going to be 1 n to what power? That's going to be 1/5. Well, is 1/5 bigger than or equal to, bigger than 1? Can be equal to 1. Is that bigger than 1? No, so this guy's going to diverge. Well, if someone gives you 1 over n to the 5th, is 5 big? That's a 5. Is 5 bigger than 1? Yes, it's bigger than 1, so this guy's going to converge. Any other ones? Then you can start, thinking a little bit outside the box. What if somebody gave you summation 1 over 2n plus 1 squared, n equals 1 to infinity? Well, how's that going to compare to summation n equals 1 to infinity of 1 over 2 to the n squared, which is going to equal to 1/2, and stuff we did a few times ago, 1 over n squared. Who's bigger, this or this? Well, here I got more numbers on bottom, and it's squared. So more numbers, a bigger number on bottom is going to make this guy smaller. So this guy's going to be bigger. What do you know about this guy? It converges. So this guy's automatically going to converge. Okay, I'll send you some homework. Again, read through your book. Make sure you get all the details that I missed. All right, bye. Stay safe.